Hey, it's Thankful Tuesday, and guess what? We're not going to spend a lot of time on Calendar Grid or our calendar collector today. In fact, I'm not even going to show you me pouring our cup to our quart container, but I'm going to show it to you very quickly updated because we have some word problems to solve today. And we know word problems can take a while sometimes. So I want to make sure that we are spending our time wisely today so that we can get in and finish Number Corner and finish it well so that we're ready to move on for the rest of our day and then ready for Number Corner tomorrow. You with me? All right, so I'm going to very quickly show you today's date, which is the 17th. And you can see the clock right there. Hopefully you very clearly see what time it is. And I will update that on our recording sheet. Then you know that today is the 11th day of Number Corner, and I am going to add another cup to our quart container. Yesterday we had 2.5 total quarts. Today, if I add another cup, guess how much we're going to have? 11 cups, so that's 2 3/4, okay? And here is one possible equation that could be written to solve this problem. And I actually need to correct a mistake that I made. So we have 11/4, which gives us 2 3/4. Okay, so I am going to write a number on this page. And I want you to look at the number, and I'm going to ask you some questions about place value in relation to the number that you're going to see here now. So after I finish writing it, I want you to read it to yourself silently in your head. I'm going to make it big. All right, now let's read it out loud. 564,378. Okay, 564,378. So now my question is, what place is the 7 in? Right, it's in the tens place. So what value does it have? How much would 7 tens be worth? Yeah, it's worth 70. You got it. So which digit is going to have the value of 4,000? Right, 4, because it's in the thousands place. Okay, and the 6 is in what place? The 10,000s. And what value does it represent? Great. 60,000. You can almost imagine it as if I'm putting zeros behind the place value that I'm talking about. So if I'm talking about 10,000s, everything else becomes a 0, and it's 60,000. All right, what is this number rounded to the nearest 100,000? 564. So if I round it to the nearest 100,000, what would I get? I hope that you're thinking 600,000, because 600,000 is closer to 564,378 than 500,000 is. Okay. Also, remember this digit when we're rounding to the 100,000s. We look at the place next door, which is the 10,000s, and if it's 5 or more, then we're rounding up. So that gives you another clue. Okay. Let me write another number here. What number is this? 5,555. So, some different questions for you. I want you to really think about this. What is the relationship between the 5 in the ones place and the 5 in the tens place? Looking for a relationship here. Both the same digit, but one is different. 5 in the tens place is 10 times as much as the 5 in the ones place. So it's 10 times greater. Okay, so then how about the relationship of the 5 in the hundreds place and the 5 in the thousands place? That's 10 times bigger. So the place value to the left is 10 times bigger than the place value to the right. And we see that especially when the digits are the same. So this is 500. In the hundreds place, it has a value of 500. In the thousands place is 5,000. So it's 500 times 10. Okay? All right, how would I write this number in expanded form? Let's write it out together. 5,000 plus, good, 500 plus 50 plus 5. Here is this number written in expanded form. All right. Now, does this help you see the relationship? Does it help you see that it's growing 10 times greater when you go into the left? I sure hope so, because we are going to work on a word problem. Some word problems today, some place value word problems, that is. And here they are. And here is the first question. Focus only on the first question right now. Read it silently to yourself really quickly. All right, so can you tell me in your own words what's happening in this story problem? Two kids rolling a dice. They roll 3 dice. They make a number with the 3 digits. One student made 368, one made 386. So the question is, are those numbers the same? Why or why not? Right, the numbers are not the same. 368 is not the same as 386. Yeah, and 386 is bigger than 368. So that's another way that we can know they're not the same. Now, what is the same about them? They have the same digits. So they have a 3, they have an 8, and they have a 6. It's just arranged in a different order, okay? So I want to push your thinking a little bit further. Let's talk about the digits in the ones place and the tens place in both of the numbers, okay? So look at the ones place in 368. Look at the tens place in 386. There's an 8 in the ones place here, and there's an 8 in the tens place. What does that mean? Yeah, so this number is 10 times, the digits 10 times bigger. Maybe we should look at just the ones place. So 8 in the ones place, 6 in the ones place. What do we know? Yeah, 6 and 8 are not the same. 8 is more than 6. You're right. What else? What about if we look at the tens place? Yeah, so we have 8 tens, we have 6 tens. 8 tens is more than 6 tens. Okay, so even though they have the same digits, they're different because of their place value. Okay, so let's look at the second question. And this time I actually want you to open up your number corner journal, because these questions are actually in there. I am on page 31. I want you to look at number 2, and I want you to work through that independently by yourself very quickly. So pause this video, and then when you come back, we're going to keep moving, okay? All right, so we're going to check your work on problem 2 a little bit later, probably not today, but the question did ask the relationship, and we went over that with the number 5,555. between the 6 and the 1s and the 6 and the 10s. So hopefully you guys were able to answer that question. Let's do the third problem. We're going to work through this one together. Simon and Coral are playing a game with dice. They each roll 3 dice and arrange the dice to form a 3-digit number. Sounds a lot like the kids from number 1. They rolled 3 dice and they created a 3-digit number. It says whoever gets the higher number is going to get 1 point. Okay, so we're playing for the highest number. Simon rolled a 4, a 5, and a 1. What number should he make? We want the biggest number, so what digit should we start with? Yeah, we probably should start with a bigger digit and work our way down to the smaller digit. So we made the number 541. Coral rolled a 3, a 2, and a 6. So what number should she make? 3, a 2, and a 6. Good. 6, 3, 2. So again, we're trying to get the highest number, so we're starting with the higher digit, and we know that because of our, we've played a game like this before, right? All right. Whose number is bigger? Right, so I can put 632 is greater than 541. So you guys should be notating this in your number corner journal as well. 632 is greater than 541. You agree? Awesome. I'll give you a moment. Make sure you are caught up. All right, did anybody say that 541 is less than 632? If you did, that is also mathematically correct because 541 is less than 632. So I can write that as well. Either one of these will work because they are true. You can write both or you can write one. It's up to you. Why is 632 though bigger than 541? Really, we can look at the hundreds place, right? 600 is worth more than 500. I'd definitely rather have $600 in my account than $500. Yes, I would. All right, so you're going to complete numbers 4 and 5 independently because I want to see what you're able to do independently. I don't want to hear or see Ms. Trammell's thinking. I want to see your thinking because that tells me how I can better help you. Okay, remember, you guys are responsible for your learning. So you're going to work on problems 4 and 5, and then we are going to go over them at a later date. So I'm actually going to leave you for today so that you can finish, and I'll see you tomorrow. Have a great afternoon. Bye-bye.